In this video, we're going to look at Bayes' theorem. And this allows you to calculate the probability of the event based on certain outcomes that have already been observed. And so, again, it uses some of the stuff we talked about previously, particularly total probability. So we can even say this: let A1, A2, up to say AN be mutually exclusive and exhaustive events. And let E be any event. And again, we have that picture of total probability that we talked about earlier. You know, you have your A1, A2, and of course all the others. We don't know how many up to AN. And then you have another event, E. This is E here. And then, of course, this is A1 intersection E, A2 intersection E, and then same things go on to between AN intersection E. And then the probability of E is going to be equal to the probability of A1 intersection E plus probability of A2 intersection E up to however many you have, plus probability of AN intersection E, like that. And also, as we said previously, again, we're doing this idea of total probability. Remember, total probability is kind of what the idea is right here. And remember, we could write this as probability of E given A1 times the probability of A1. And this was probability of E given A2 times the probability of A2, probability of E given AN times the probability of AN, like that. So we have, this is probability of E, and then also, let's say for any particular AI, we have probability of AI. So for any particular AI, we have PAI intersection E is going to be equal to P E AI P AI. So now, let's say if we want to find the probability of AI given E is going to be equal to the probability, we always had from the past, if we're doing conditional probability, the intersection of these two divided by the probability of this. But now we can substitute this and this. So in other words, for the denominator, we can substitute this. For the numerator, we can substitute this. Now I'm going to write these with the PAIs first. It sometimes makes it a little bit more convenient. So then we can finally say the probability of AI given E is going to be equal to the probability, first substituting this for this, and we have this. So once again, all I did was in the place of probability of E, I put this, and in place of this, I put this, just rearrange things a little bit. Now I rearranged the AIs, I put them first because it kind of makes this easy to memorize. Because if you want probability of AI intersection E, then you just have probability of AI, whichever AI that is. It could be 1, 2, up to N, times the same thing as this, but just reversed. Instead of probability of A given E, you have probability of E given AI. And same thing down here. You have PAI, PEAI, etc. And this is called Bayes' theorem. And we'll do an example. And so let's do an example. The apple juice factory found that there was a breakdown in their pasteurizing system. Last month, all the bottles they shipped were not pasteurized. And probably a different way to say this would be say they weren't all pasteurized. And in fact, of those shipped, 50% of the bottles of juice made from Jones's farm. So, Jones supplied oranges, or excuse me, apples, and 50% of those bottles